Hello guys, today I'm going to explain to you the phenomena of diffraction of light by a single slit. You know that light has a wave nature, and any wave that reaches a narrow slit, it is diffracted. What do I mean by the word narrow? Narrow means that the width of the slit must not exceed 1000 times the wavelength of the wave. So, if this width of the slit, which we will call small a, is less or equal to 1000 times lambda, then we observe diffraction. What is meant by diffraction? Simply, it is a phenomena where a wave reaches unexpected areas. So assume that the slit is big enough, then the wave reaches it, it continues and reaches this point on the screen. But since there is diffraction, then light reaches unexpected areas as you see. So this is the diffraction of light. And now we will talk about observations. What do we observe when light is diffracted? On the screen, let me talk about this figure. We see something called fringes. Fringe, etc. We call these as bright fringes. And each two bright fringes are separated by one dark fringe, this point. It is called dark fringe. So the first observation is that we observe alternating bright and dark fringes. Why alternating? Because bright, dark, etc. This is the first observation. Second one, this fringe, which is the central fringe, we will call it central fringe, is double in width compared to the others. This is the second observation. The third observation, if we compare the direction of the slit and the direction of the fringe pattern. So they are orthogonal, which means that since the slit is vertical, the pattern is horizontal. Now if we flip the slit to be horizontal, we observe a vertical pattern. These are the main observations of the pattern. Finally, we will talk about calculations. Now, what is the relation between the width of the fringe and the width of the slit? Is there any relation? Yes, of course. I will talk directly about this relation. Theta is equal to lambda A over A. What is theta? As you see, let me take this fringe. It is bounded between two lines, let me say, dark lines or extreme lines. Now, if I draw them here, I can see these two extreme lines and the bright fringe is bounded between them. So there is an angle here, is called theta. Let me say theta. So theta is the angle of the fringe. We call it is the angular width of the fringe, and the distance from this point to that point is called the linear width of the fringe. Angular width and linear width. And now I'm writing C, LC and theta C to mean that this is the linear width of the central fringe and this is the angular width of the central fringe. Now, physically, I'm not going to show it, but it is simple to show that theta, the angular width of any fringe, is equal to lambda wavelength divided by A, the width of the slit. Now this means that if I increase lambda, theta must increase, and if I increase A, theta must decrease. Let me see this if it is true. This is an experiment, so I will decrease the wavelength. If I decrease the wavelength, theta must decrease too. See please, it decreases as you see, which means that the fringes shrink, so theta decreases also. And if I increase lambda, the theta increases too. Now what's about A? If I increase A, theta must decrease as you see, and if I decrease A, theta must increase also. This is true. Now theta equals lambda over A, but for the central one, for the central fringe, I may say that theta C is equal to 2 lambda over A because the central fringe is double the others. So theta C equal to lambda over A. Now, geometrically, I can relate theta C and LC with the distance from this, which is the slit, to here. Let me write here, slit. So the distance from here to there is called capital D. Now from geometry we know that the length of the arc is equal to theta multiplied by the radius. So LC must be equal to theta D. LC is equal to theta C times D, which means that theta C is equal to LC over D. Now comparing these two values, we get theta C equal to 2 lambda over A, then 2 lambda over A equal LC over D, or LC is equal to 2 lambda D over A. And thus we can say L, which is the linear width of any other slit, is equal to lambda D over A and not 2 lambda D over A. Finally, I want to show you the intensity distribution. What does it mean? How does light as intensity is distributed on the screen? Let me see this important one. So, on the central fringe at angle 0, which is the point, we get the maximum intensity of light. And as we go away, the intensity decreases. In the first bright fringe, we get most of light, and in other fringes, as we see here, for example, in the other fringes, light becomes dimmer and dimmer, so which means that less intensity in the other fringes.